Alrighty, this is the Amusement Park problem, 2002 AP Free Response problem. And we're going to use the TI-84. We have the rate at which people are entering the park is given by this E of t value right here. Then the rate at which people are leaving the park is given by L of t, E for entering, L for leaving. They're both measured in people per hour. And time is in hours after midnight. That's going to come into play. The functions are both valid for 9 to 23, which is effectively 9 a.m. to 11 p.m., the hours during which the park is open. Time equals 9, there's nobody in the park because the park is just opening. So the first question is, how many people have entered the park by 5 p.m., which is time equals 17? So the way you're going to set up A is you're going to integrate the E of t function, and you're going to integrate it on the limits of integration from 9 a.m. to 5 p.m., so 9 to 17. We're going to go ahead and use our calculator for this. And let's get ourselves set up. We're going to go to, turn it on, first of all, haha. I'm going to go to y equals, and I'm going to clear out what's in here, and I'm going to type in the E of t function, so 15,600 divided by, make sure you put your entire denominator in parentheses. So we'll use x squared minus 24x plus 160. And notice I am using x because the graphing screen won't take a t. And basically what I want to do is integrate what is in that y1. So I'm going to go back to my home screen. So do second quit, come back to the home screen. And I want to go to integrate. And to get to integrate, we are going to do alpha F2, and then I want choice 4, which is the integral. I'm going to integrate from 9 to 17, and I want to integrate the function that I have in my y1. So I'm going to go to vars, yvars, function y1, and of course I'm going to put in dx right here. You can tell I'm at school doing this as the bell is ringing. So I got 6,004. So what we want to do is round this to the nearest person because it says round to the nearest whole number here. So my answer is going to be just 6,004 people. And that is how you do the first one. For the second one, it says the price of admission is $15 until 5 p.m. and after 5, the price of admission goes to $11. How many dollars are collected on the given day? So first of all, we're rounding our answer to the nearest whole number. We had 6,004 people come in on the hours of 9 a.m. to 5 p.m. So they are coming in at $15 an hour. So that's a simple multiplication problem, which I'm still going to do on my calculator. So I'm going to do 6,004 and, 6,004 times 15. This is probably the one exception to rounding off in the middle of a calculation. It is okay to round off during this calculation because you have whole numbers of people. You don't have partial people. So this is $90,060 for the people that came between 9 and 5. So there you go. So now I got to figure out how many people are coming between 5 p.m., which is 17 here, and 11 p.m., which is 23. So I'm integrating the E of t function from 17 to 23. Go back to my calculator, and I'm going to do, I think I can go up and grab this and bring it in, and then I'm just going to go back over to my limits, change them to be 17 and 23. And I hit the enter button, and I have 1,271 people coming on the hours from 5 p.m. to 11 p.m. So 1,271 people now times $11 per hour. It's $13,981. Add that to the $90,060 we collected otherwise during the day, and the total amount we have collected is $104,041. So that is your answer to part B. We've done A over here and B. So now they're asking us, they're saying H is basically the rate in E minus the rate out L during the entire day, 9 a.m. to 11 p.m. They want to know, or they're telling us that the value of H of 17 to the nearest whole number is 3725. They want us to find H prime of 17 and explain the meaning of both H of 17 and H prime of 17. So H prime, what we're going to do here is label this C. H prime of t, using the fundamental theorem of calculus, I just have to plug in t into each of these x's. So H prime of t equals E of t minus L of t. And then they want to know at time equals 17. So H prime of 17 equals E of 17 minus L of 17. And I can just go to my E and my L and plug in 17 into both. When I plug in into both, what I'm going to get out, and I'm not going to show you that on my calculator because it's a simple plug-in, but I'm going to get out negative 380.281. Okay, so we know that there were 3,725 people in the park at 5 p.m. And that's what H of 17 is. So they said, what is H of 17 and what is H prime of 17? H of 17 says there are 3,725 people in the park at 5 p.m. H prime of 17 says that this number, the number of people in the park at 5 p.m. is decreasing at a rate of, and make sure since you said decreasing that you're changing it to positive terms, so 380.281 people per hour. Okay, and you can even say at a rate of approximately 380 people per hour in the spirit of not having partial people. All right, the last part of this problem, we've done part C. The last part of the problem says, at what time does the model predict that the number of people in the park is at a maximum? So this is an optimization problem here. And what we need is a little chart of values. We need time equals 9 a.m., time equals 11 p.m., and then we're trying to find the number of people in the park. So the number of people in the park is our H of t, which if you recall was E of t. Sorry, we need to know, we do need to know the number of people in the park. We're trying to find out where it's a maximum, but we need to know where H of t equals the integral of E of t minus L of t dt. Well, in order to complete this table, I'm going to need a critical value. And the critical value is where the derivative H prime of t, which is equal to just E of t minus L of t, is equal to 0. So what I suggest doing is going to your calculator, and we already have in our y equals, we already have the rate at which people are entering the park. So let's go ahead and in a new equation, y4 will do the rate at which people are leaving the park, which is 9890 divided by, and then in parentheses in the denominator, x squared minus 38x plus 370, close parentheses, and I only want to see y4 and y1 because I want to find the intersection of those. So just make sure your y2 and your y3, which I don't like to remove, I like them always to be there. We don't need them for this problem, but I'm going to leave them there. I just don't want to see them, so my equal signs aren't highlighted. So now here's the problem. If I go to the graph screen, I have no idea what my window is. I know that I'm dealing with thousands of people in the park. I'm seeing some graphs, which is actually kind of amazing, considering I don't know what my window is. But basically what I want is my x-axis to be the time. So I want to start at 9. I'm going to go to 23. And the number of people in the park, we know it's at 0, right? We know it starts at 0 at 9 a.m. It's going to end at 0 at 11 p.m. And I don't know how many people are going to get into the park, but let's put it at like 15,000. I'm guessing there. We know that at one point there's 3,725 people in the park, but let's just see what else we see. Looks like there's the rate at which people are entering. There's the rate at which people are leaving. It definitely did not need to go way up to 15,000, so I'm going to do my window and bring it way down. I just realized these are rates that I'm graphing, not the actual numbers, so I probably could have gotten away with 1,000. And look at me. I did a nice job of guessing there. Okay, so it looks like we've got one critical point, and we're going to find it by doing second calc intersect, guess 1, guess 2, guess 3. And that happens at 15.7948. So 15.7948. Now, at time equals 9, we have 0 people in the park. And at time equals 11 p.m., we also better have 0 people in the park because the park is closing. So the maximum number of people in the park will have to be at 15.794. And honestly, they only asked us at what time that will happen. They didn't ask us how many people are in the park. So this is all we really need. We know that this graph, go back to the graph actually, you can tell this is the number of people coming in, this is the number of people leaving. Clearly, because the number of people are coming in is decreasing here and people leaving is increasing here, this is going to be the maximum number of people in the park. So that's at 15.794 or 795, which is otherwise known as, say, 3 p.m. and change, but just leave it as 15.794.